Hey guys, Mr. Riz here to help you out on the 10.4. We're going to be looking at the inverses of matrices. So what is an inverse of a matrix? So if we have this example here of the 2, 1, 3, 0, a 2 by 2 matrix here, the inverse of any matrix is that such that if we multiply by the inverse, we get this identity matrix, which the identity matrix, remember, is like a diagonal line of ones and then everything else is 0. So 1, 0, 0, 1. All right, so in order to figure this out, what we got to do is basically set up a problem here where we say that the matrix we have here, 2, 1, 3, 0, times this, I don't know, unknown inverse matrix has to equal 1, 0, 0, 1. So we know we can multiply two things together, right? I can multiply, or we can multiply this row by this column. So 2 times W is 2W, 1 times Y is Y. So that's how we get our first element. Next, we can multiply 2 times x, which is 2x, 1 times z is z. And we move on to this next row here. 3 times w is 3w, 0 times y is 0y. And then we can go through and multiply 3 times x is 3x, 0 times z is 0z. So we have this expression here. Now we'll look to the identity matrix, and we actually can set up a bunch of different problems. We know that this 2w plus y has to equal 1. And 3w plus 0y has to equal 0. That's a system of equations that we can go through and solve. So we can solve for w, figure out what that has to equal. W would have to equal 0 then. And we can use that to solve for y. And the same thing we can do the other side, solve for x, and we can solve for z, and we figure those out. And we can always go back to double check that if we took the identity matrix and multiply, or the inverse matrix by the actual matrix, we get the identity matrix in the end. Okay. One thing that you have to watch out for is that the inverse matrix doesn't always work out. And so we'll have to watch out, like this example here, if we go through the steps, it just end up not working out. When we combine our two together, we don't get the inverse matrix. Okay, so let's go through this step here. I need to pause to get my screen, my marker here, and we'll try this next one. All right, here we go. So got this working. So let's go through what we want to do here. We're going to set up a problem because if we take 1, 5, 1, 3, and we're going to have to multiply it by some w, x, y, z to get an identity matrix of 1, 0, 0, 1. Okay, so let's set up our problem. If we did the first row, first column, 1 times w is w, 5 times y is 5y. Okay. Then let's do the next one here. 1 times 5, or 1 times x is 1x, 5 times z is 5z. You know that this has got to equal 1, 0. All right, next we can do this bottom row with the first column. 1 times w is w, 3 times y is 3y. You know that's got to equal 0 here to match up. And then 1 times x is x, 3 times z is 3z. That's got to equal 1. So we end up basically making two systems of equations. We have one here where we got w plus 5y has to equal 1, and another one here of w plus 3y has to equal 0. Sorry, what's going on? Okay, then we have another problem over here where we got like x plus 5z equals 0, and x plus 3z equals 1. Okay, so it's kind of nice to treat these as separate problems to get our separate answer here. So I'm going to do this one first. Now, what I would do is subtract these two columns together. So w minus w goes away. 5y minus 3y is 2y, and 1 minus 0 is 0. And if we divide, that means y has to equal 0. So we look at our chart here, this has to be 0. Now we can use that information to help figure out what our w is. If we know y is 0, that means that w plus 5 times 0 has to equal 1. Wait, no, actually, you know what? I made a mistake. I'm like, that doesn't make sense right now. That won't work for both problems. Oh boy, I forgot this part here. This makes sense. 1 minus 0 is 1. So if we divide 1 by 2, we get 1/2. So y is 1/2. All right, now let's plug that in. If we do W plus 5 times a half, that equals 1. So W plus, that'd be what, 2.5 equals 1. We can subtract W would equal negative 1.5. That's negative 3 over 2 if you like fractions. So that's what W equals, negative 3 over 2. Okay, so let's repeat that step over here with the x's and the z's. All right, I think it might be easier to subtract the x's here. X minus x goes away. 5z minus 3z is 2z. 0 minus 1 is negative 1. So z would equal negative 1/2. All right, and we can use that information to figure out what x is. If x plus 5 times a negative 1/2 has to equal 0, so it would be x minus 2.5 equals 0. X would equal positive 2.5, or that's also 5 over 2 if we're using fractions here. All right, and there we go. There is the inverse of that matrix. And so today's goal is to make sure we can find these inverses here. Okay. So for any matrix AB, the determinant of a 2x2 matrix is denoted by the det of A. That means the determinant. That value is equal to A times D minus B times C. So an inverse of A is denoted by A to the negative 1 power exists only as long as the determinant does not equal 0. Okay, so if we go back to this first problem here, if we did A times D minus B times C, so A times D, which is 1 times 1, and then if we subtract B times C, negative 1 times negative 1, that would be 1 minus 1, that equals 0. If we ever get a determinant that equals 0, the inverse does not exist. Over here, we can see if we did A times D, 1 times 3 is 3, and we subtract 1 times 5 is 5, that does not equal 0, that's negative 2. So we can find the inverse. So that's a good way to check if we have to find the inverse of a matrix, whether, we should waste our time doing all that stuff. Okay, so next, all right, next let's talk about another great purpose of the determinant. So if we can look at the determinant to see if an inverse actually exists, it's great. The other thing is we can use that A times D minus B times C can help us find the inverse. If we look at it, the inverse of a matrix is equal to the matrix times 1 over the determinant. So in this example here, if we go cross multiply, 4 times 2 is 8, minus the negative 1 here, that's 9. We actually take our matrix and multiply it. And what happened here? Oh, when we flip it, that gives us the inverse. So what we have to do here, the inverse exists is if we flip the rows, flip everything around. Okay, so instead of being basically crisscross applesauce here and then multiply by 1 over the determinant, we get the inverse. So 4, 2 switches across to 2, 4. Negative 1, 1 flips across to 1, negative 1. And if we multiply that matrix by 1 over 9, the determinant, we end up getting the inverse value. Okay. So let's use that technique to find this one here. So we could use your W, X, Y, Z, or we can go through. So first let's find the determinant, or look at this one here. If we try to do the determinant, 6 times 4 is what? 6 times 4 is 24, minus 3 times 8 is 24. Okay, so that's 0. We can't do that here, so we're not even going to try to do the inverse. All right. Next, if we want to go through and find the inverse of a bigger one, we can go through and do A, B, C, Q, R, S, W, Z, or we can use a calculator here. So let me show you guys a trick on the calculator. So oh, I don't like how they did that there. Okay, let's talk about a calculator. Our calculator can do some work. Now let's look at some of the matrices that we've already done, like this first example here, this 2, 1, 3, 0. If we have a graphing calculator, I want to make sure that you guys can see this here. There is a button here. If we press second and then the x to the negative 1 power, we get this matrices here, and we can have a lot of different matrices stored. Now right here I have matrix A, and I have a 1 by 1 next to it, but if I want to change it, I'm going to go to edit matrix A, press enter. Well, I can change the dimensions of this here, and I'm going to make this a 2 by 2 matrix. Now this will allow us to type in numbers here. And so we got A, 1, 1. Remember A, row 1, column 1. Okay, I'm going to say that's a 2, that's a 1, that's a 3, and that's a 0. All right. Now I'm going to quit out of here. And if I go to that matrix menu again, and I just click on matrix A and press enter, we can see, oh, can't see my head here. We actually get that matrix to print out. It's stored into our calculator. We can do a lot of different things with that matrix. Now, the one thing that we're going to do first is, well, I can do second 3. Can I do this? Oh, I can do matrix A times 3, and you can see it's the exact same matrix, but everything's multiplied by 3. We can have the calculator do that work for us. We could also have multiple matrices, and so we can add them together or subtract them or do anything like that. A couple nice things about this, if we go second matrix here, in the second column, this math column actually gives us a list of operations we can do. And this first one here, DET, is the determinant value. So if we didn't feel like doing that cross section there, and it gets a little bit more complicated when we have like a 3 by 3 or 4 by 4, we can use the calculator here. So we got to do second to get the determinant, and then do second matrix here to choose matrix A. So we basically make a statement, say, find the determinant of matrix A, press enter, and there we go, that's -3, because that would work out. Oh, I was looking at this one here, but 2 times 0 is 0, 3 times 1 is 3, 0 minus 3 is -3. All right, so let's talk about what we also can do. If we go second matrix, and I click matrix A, and then if we actually don't press second, but click this button here, x to the -1, that is the inverse function here. We can press enter here, and we get those numbers. Now, if we look at our work here, we got 0, 1, or 0, 1/3, 1, -2/3, which looks pretty close. If we wanted to double check, we could press math, enter, enter, and there we go, we have it. So we can use the calculator to find inverses. So the biggest thing I want you guys to take away, especially when we're working with matrices here, is like, there's a lot of tools that can help us out. Now, those tools are all based off of mathematical facts and equations that we went through at the beginning, but we can use that here. So like this first problem here, if we want to find the inverse of P, all right, let's do second matrix here. I'm going to go, I'll do edit, I'm going to do matrix B here. I'll make that a 2 by 2. I could reuse matrix A if I want, but I'd have to edit it. We got -4, then we got 2, then we got -6, and then 3. All right, so if we want to find the inverse here, we're going to go to second matrix. We're going to choose matrix B, and I'm going to press that button here to get to the -1 power. All right, we get an error here. Okay, so this is scary. What we should do is double check our work here. If we were to multiply straight across, -4 times 3 is -12. -6 times 2 is -12. That would equal 0. So that matrix inverse does not exist. Okay, and that can happen. All right, let's check out Q here. Let's find the inverse of that. So, oh, wrong button here, second quit. Let's go to the matrix menu here. Let's edit matrix A. Let's make it 2 by 2. We got 7, 3, 2, 1. This one should have an inverse. So, okay, if we do second matrix, we call matrix A, and then we say do the inverse of it. Boom, there's the inverse. So it does all the work for us. That one's actually kind of nice. It's almost like flipped up what we got there, but 1, -3, -2, 1, 7. Now, where it really is helpful is when we have a 3 by 3. Oh. So let's do this one here. So second matrix, let's edit matrix A again. But this time, let's make it a 3 by 3. You can see it adds another row, adds another column. We got 5, 1, -1, 2, 0, 5, 1, 0, 2. All right. So we're going to quit out. We're going to go to second matrix. We're going to call matrix A. Let's find the inverse of it. There we go. There's the inverse of matrix A. Okay, so just one thing to note here is that matrix can be found a couple different ways by using the equation or using the 1 over the determinant of it, using the opposite of the expression. Now, that gets a little bit more complicated when we have a 3 by 3. It even gets more complicated with a 4 by 4. And as we increase the size of it, it gets crazier and crazier. But that's why we have tools. Some people have done that for us, and we can use it to help us out. All right, guys, so that's what we're going to be checking out here in 10.4. I'll see you guys next for 10.5. All right, have a good one.